We're now going to explore two other reactions. We're going to look at substitution reactions and we're going to look at combustion reactions. Let's start with substitution. This is where there has been an exchange of functional groups. And the three that we need to know is when we take an alcohol and substitute it with a haloalkane. With a hydrogen chloride or a hydrogen bromide or a hydrogen iodide to produce a haloalkane. Hydrolysis, so bases or water with haloalkanes produced alcohol. And finally, haloalkanes from alkanes in the presence of heat or light. So, an alcohol can become a haloalkane by adding a hydrogen bromide or a hydrogen chloride or a hydrogen iodide or a hydrogen fluoride. And what happens is, under the right conditions, the OH group from the alcohol comes off. It joins up with the water, at least with the hydrogen, to form water. And then you are left with the bromine over here being substituted in and now being on the hydrocarbon, which now becomes a haloalkane. The next one is when a haloalkane becomes an alcohol. Well, that's exactly the opposite thing, isn't it? So in this case, the bromine is going to come off and join onto the potassium. The OH is going to come off and join up with the hydrocarbon, and we're going to land up with an alcohol and a potassium bromide or a hydrogen bromide. Notice the conditions here. We need ethanol in order for that to happen. And then the next one is for haloalkane. So here we have got 2 chlorines on this, so it is 1,3-dichloro-pent, at least propane. And then if you put in the presence of heat and light with hydrogen, the hydrogens are going to go onto the molecule and they're going to kick the chlorines out and we're going to get chlorine. This is obviously also a reversible reaction, so if you put it in the dark, maybe the opposite would happen. The next reaction that we're interested in is a combustion reaction. And a combustion reaction, you get an alkane, C8, H16 plus 2, 18, plus oxygen. Always, combustion reactions, very important. Your products, carbon dioxide and water. Alkanes and alkynes will undergo a very similar reaction. Hydrocarbons burn as fossil fuels. They transfer chemical energy into heat energy. Let's take a different alkane. C6H14 plus oxygen is going to give me, again, carbon dioxide plus water. I've got 2 out of my 3 marks. The rest is fairly easy, though. I'm going to put a 6 there because I've got 6 carbons over there. Then I know I've got 14 hydrogens, so I'm going to put a 7 in front over there. 2 times 7 equals 14. And then I'm going to say 6 times 2 gives me 12. Plus 7 times 1 is going to be 19 oxygens. So in terms of O2 molecules, I need 9.5 O2 molecules. If I want to now balance that, what I'm going to do is I'm going to run a 2 all the way through, and I'm going to land up with, my balancing numbers will be 2 C6H14 plus 19 oxygens gives me 12 carbon dioxides and 14 waters. Alcohols are also able to burn in oxygen to yield water and carbon dioxide, and you would work at the balancing fairly similarly. Methanol combustion, ethanol combustion, add the oxygen and you get carbon dioxide and water.